The expression f of x equals 2 times x cubed minus p times x squared plus qx minus 10 is divisible by x minus 1 and has a remainder negative 6 when divided by x plus 1. Find part 1 the values of the constants p and q, and part 2 the factors of f of x. Now we're going to be using the remainder and factor theorem. Since our f of x is divisible by x minus 1, we can apply the factor theorem here and the remainder theorem for x plus 1, since there's a remainder of negative 6. So our factor theorem will tell us that f of 1 is equal to 0, since x minus 1 is a factor, i.e. our expression is divisible by x minus 1. So we're going to have 2 times 1 cubed minus p times 1 squared plus q times 1 minus 10 equals 0. This is going to give me 2. Let's put in my constants together. So 2 minus 10 minus p plus q equals 0. So I'm going to get negative 8 is equal to adding p to both sides and subtracting q from both sides. So this is going to be my equation 1. Now since I'm trying to find two unknowns, p and q, I am going to be solving a pair of simultaneous equations. So I have my first equation, and for my second equation, I'm going to use the remainder theorem with this information. So by the remainder theorem, f of negative 1 is equal to negative 6. So that's going to give us 2 times negative 1 cubed minus p times negative 1 squared plus q times negative 1 minus 10 is equal to negative 6. Negative 1 all cubed is negative 1, so this is negative 2. Putting my constants together again, minus 10. Negative 1 squared is positive 1, so this will be negative p, and this gives me negative q is equal to negative 6. Negative 12 minus p minus q is equal to negative 6. So I'm going to add 6 to both sides. So I'm going to get negative 6 on the left, and I'm going to add p and q to both sides. So I'm going to get that p plus q equals negative 6, and this is my second equation. And I'm just going to solve those two equations simultaneously. So p minus q is equal to negative 8, and p plus q is equal to negative 6. So subtracting, negative 2q is equal to negative 2. So q is equal to 1. And then just subbing in that q is 1. Let's see what that gives us. So p plus 1 equals negative 6. So p would have to be negative 7. So my values for p and q are negative 7 and 1 respectively. So I'll just write then that f of x is equal to 2 times x cubed. Now p is negative 7, so negative p will be positive 7. That's positive 7x squared. Q is 1, so that's plus x minus 10. So this is my expression for f of x. So part 1 is completed. Now for part 2, where we want to determine the factors. Now notice we already know one factor, x minus 1. So I'm going to simply divide my expression f of x by x minus 1, and that will give me my remaining factors. So this part here will be my constant. Now I'm going to be using synthetic division, but you can use whichever form of division you are familiar with. So my coefficients 2, 7, 1 and negative 10, and I am dividing by x minus 1. I bring down, I get 2, negative 1 by 2, that's negative 2, subtract, I get 9, negative 1 by 9 is negative 9, subtract, I get 10, negative 1 by negative 10, negative 10, subtract, I get 0, which I should get since this is my remainder. So f of x equals x minus 1 times 2x squared plus 9x plus 10, which gives me x minus 1 times, and let's see if this can factorize, 2x, x, and what would be our factors? 5 here and a 2 here, both positive. So there, we have factorized. Those are our solutions. Thank you.